we would like to find the value of a. Now to do this, here we can rewrite this given equation as 2 to the power of a plus 2 to the power of 2. Then we have this to the power of a plus 2 to the power of 3. We have this to the power of a equals to 39. Now here, recall the rules of indices that says that when you have a to the power of m, n is the same thing as a to the power of n, n. So I'm going to be using this rule. Here we're going to have 2 to the power of a plus 2 to the power of a squared plus 2 to the power of a cube equals to 39. This makes sense. Now let's do it this way. Let y to be equals to 2 to the power of a. So here we're going to have y plus y squared plus y cube equals to 39. Now, if you look at this, you can guess what is going to be the value of y. But if you guess right here, you can say that if y equals to 3, then if you plug in 3, we're going to have 39. But the question is, how many roots do we have for y? How many roots do we have for y? Is it just 1, 2, 3? So this is something that needs answers to. So here, let's do something here. I can write this as y cube plus y squared plus y equals to 27 plus 9 plus 3. Look at this. 27 plus 9 is going to be 36. 36 plus 3 is going to be 39. So that is when y equals to 3, then this equation can be satisfied. But how many equations do we have for y? This is something we need to cross-check. So here I'm going to write this as saying y cube plus y squared plus y minus 27 minus 9 minus 3 equals to 0. Now, writing this given equation, here I can say that y cube minus 3 cube, that is 27 is 3 cube, plus y squared minus 3 squared, 9 is 3 squared, plus y minus 3 equals to 0. So they are still the same. Now, here, solving this further, I want you to recall from algebra. In algebra, if you have a cube minus b cube, here, this is going to be a minus b. Okay, so here we have a squared plus ab minus plus b squared. So I'm going to be using this for this. So now my y cube minus 3 cube, using this form, here we're going to have y minus 3 y squared plus 3y plus 3 squared, which is 9. So this is what we have. Plus, here we having y squared minus 3 squared, difference of two squares. We can have y plus 3, y minus 3, plus the last one, y minus 3, equals to 0. Now, if you have a look at this given equation, here we can see that y minus 3 is common to every term. So we can factor that out, y minus 3, and here we're going to be left with y squared plus 3y plus 9 plus, in this term, we are left with y plus 3. Y plus 3, and here you're going to be left with 1 equals to 0. Now, next slide. So here we have y minus 3. given. So if you look at the previous slide, if you simplify that, you can just back it up. Here you're going to have y squared plus 4y plus 13 equals to 0. Now here you can say that y minus 3 equals to 0, and you can say that y squared plus 4y plus 13 equals to 0. Let's deal with this. This is a quadratic equation. So here you can say that a equals to 1. So you are equating the coefficient, b equals to 4, and c equals to 3. So here we have y to be equals to minus b plus or minus root b squared minus 4ac over 2a. So here minus b, which is minus 4, plus or minus square root of b squared, which is 4 squared, minus 4 times a, which is 1, c, which is what? Which is 3. Divided by 2a, which is still going to be 2. So here you have minus 4 plus or minus square root of 4 squared is 16. 4 times 1 times, oh, this is c is 13. Yeah. 4 times 13 is going to be what? 52. Everything over 2. Simplifying further, here we're going to have y to be equals to minus 4 plus or minus square root of 16 minus 52 is going to be negative 36 over 2. So here you have no real solution. So here we have no real solution for y. So coming back to this, so here we can say that y minus 3 equals to 0, which implies that y equals to 3. Recall from the previous slide that we say that let 2 to the power of a to be equals to y. Okay? So here we have 2 to the power of a to be equals to 3. Applying logarithm to both sides. So we have this. So when you move the power of the logarithm to the back, we have a log 2 equals to log 3. So to get the value of a, we have a to be equals to log 3 over log 2. So finally, you can say that a equals to log 3 base 2. Why? Because they are having the same base. So you can have the value of a like this. If you plug in this into the given equation, then you should get 39. This is where I'm going to stop. Thank you very much for watching. If you find this very insightful, please don't forget to share, like, and also subscribe for more Olympiad problems. Thank you.